Okay, starting our recording. This is our group 11, lesson 9 meeting, and we'll go from there. So we got Mariella and Brianna and Mitzi. Okay, how did you guys do on this chapter? I was kind of having a,
It's a
I
really
think,
long one.
yeah, I feel like I'm always having a hard time with these things.
Reading a lot.
Yeah, yeah, a lot of writing, but the I have a question for you on the A, the significance level. It says, I wasn't really clear, but it looked like the formula for this, and I just went to the answer sheet to kind of look at it, what the formula was, because I couldn't figure it out. But it's actually finding the z-score. It's the same formula we used, right? I don't
Yes.
understand how do we use the significance level? Do we compare it or do we just plug that in?
Where we're using city score formula
No, the significant level, the A, the small
and
a.
the alpha,
Yeah, how do we plug that in?
how we found the alpha.
Yeah, how do we find the alpha? Or do we find the alpha?
Mhm. Or theta it's equal to alpha.
Is it? Is that what it is? Because it says it they gives you a level of, let's say, 0.05
Mm-hmm.
for the z-score. I mean for the alpha.
For the alpha.
I don't
Mhm.
know I don't know what to do with that number. Should we? Because yeah, maybe it's just me, but I kept reading through it and I didn't understand. Maybe I have to go back. I do have to go back and read it again. Um, but anyways, that's probably just me. Did you guys want to take a crack at the quiz, or did you guys have questions?
We can start the quiz and just work through it.
Yeah, because like for me, number 5, the work example about the cardiac arrest in our reading, I didn't understand how they got number step 3.
Number what?
Number 3. So if you look at the lesson,
Yeah,
lesson
the
9,
preparation assignment.
yeah, number 5, um, worked example, perceived health after a cardiac arrest. Did you see that one?
Question number 5 on the preparation assignment. You say?
No, in the
In
notes.
um, lesson 9 online when you read through it.
The meaning of observations, the history, that.
Um, let me show you my page. Let me share my
Yes,
screen.
please.
So
Mañana va a ser.
what? Can you see my screen?
Okay. Point
Yeah,
number 5. Okay.
yeah. I
I
don't
was
know.
listening question number 5.
Oh, I I know this. This makes sense to me, but I couldn't figure out where they got this 47.2, and is it from the quantitative data set? See, I don't see it in here either. Did you guys figure that out?
Let me check. Let me check.
Oh, there it is. That's the mean. Never mind. I see it right there. Is that right? 80, yeah, 47.82. Okay. And then, but then also this one right here, the number 50. Where does that come from? It comes from this too. Maybe I'm just not really reading this. Yeah, it does. Never mind. I got it now. Okay. It's just me. I'm slow. Okay. All right. You want me to just pick the quiz up so we can look at it
Okay.
together? Actually, let me stop my sharing. We can go to quiz.
Mariana, cuidado. Mañana vas a ir. Mañana vas a ir. Mañana vas.
Okay. All right.
Sorry, girls. My
Yeah.
little child is sick and she has to stay at home.
Oh.
And she's asking for school. I want to go to school. I want to go to
Oh.
school today.
Poor thing. Poor thing. Okay.
Oh,
All right. So let me put my screen back up. Then we can just kind of go through the quiz. Are you ready through the quiz?
yes.
Yeah.
I am.
Okay. Okay. So oh, whoops, wrong assignment. Sorry, girl. Okay. While you're required to work together, each one. Okay. Then the normal probability applet is open. So do not round into your. So we have to round to 3 decimal places. Okay. Which hypothesis involves equality? That's a null hypothesis, right? I'm on number 3. Are you ahead of us, Brianna?
No, I'm on number 3. I'm just.
Okay.
Which hypothesis involves equality? In the reading we find that that's the null hypothesis.
Yeah.
That one there. Okay, the p-value is the probability of obtaining the sample statistic, at least as extreme as the one actually observed. So we use this information for the next question. Remember that the p-value is probability of obtaining a sample statistic. At least, okay, we know that. When computing the p-value, which hypothesis do you assume to be true? That's the null, right?
No.
Okay. Okay, so number 5. For two-tailed tests, it's going to be this one, right? I know these parts, but I know we're going to get into ones I don't know. So two-tailed test is not equal to. Not right.
Equal.
What was that? So you want to do the next one?
Number 6.
Okay.
Yeah. The first one?
Yeah, the less than, right?
Yeah.
First one, yes?
Yes. Yes. So that means in the next one.
It's the other way.
Yeah, number 2, right?
Second one, no?
Yes. Yes. Okay. Okay.
Girl, give me just 1 minute. I want to energize my computer.
Okay. Remember, return the outcome of the hypothesis test by comparing the p-value level or significance level. Okay. Which relationship result in failing to reject the hypothesis?
Yeah, number 8. No?
Number 8. Which relationship failing the hypothesis?
Wow.
Okay. Failing to reject the null hypothesis.
Yeah.
So this
Which
one is Failing to reject the null hypothesis. Failing to reject it. Well, what I have here in my notes is if p-value is small, the z-score is very large, far from 0. But
The last one.
yeah, but does that mean failing the null hypothesis?
Sorry?
Because it says here would result in failing to reject the null hypothesis.
In failing, no?
Yeah, that's where I'm getting thrown off. Brianne, what do you think? Failing to reject. See here.
Well, I'm reading 4.5 in the notes. It's type 1 and type 2 errors.
Yeah, but the answers here are not the type 1, type 2. It's p minus value, or no, p-value is either greater than, less than significance, or greater than or less than z.
I think it's p-value is the first one, maybe.
As this one says that remember the determine the outcome hypothesis test by comparing the p-value to the level of oh yeah. The level, okay, so the level of significance, failing to reject the null hypothesis. We didn't reject it. The p-value is greater than. So what is the level of significance again? Is it, the level of significance is, if the p-value is low, reject the null. Is that right? How do you say the p-value is small enough to reject? That number is called the level of significance. So I guess if it's low, would that be, but it doesn't say great. Oh yeah, you're right. If the p-value is less than the level, we reject the null hypothesis, but then we fail to reject the null hypothesis is what you're saying. So it is this one, right?
The first one, yes?
Yeah, that's what Brianne said.
Yeah.
So smart. That's the only reason why we get good grades on these quizzes. Which result would we rejecting the null hypothesis? It's the second one then, right?
The second one, yes. Information is really
they believe average claim is 1,500. Okay. Which of the following is the appropriate alternative hypothesis? The average claim is greater than.
Greater than, right? No?
Yeah, number 3.
Number 3, yes.
Yeah. Is that what you have, Brianne?
Yeah.
Okay,
well, in the reading, it says that an alternative could be include greater than, less than, or not equal to. So why are we picking greater than?
As it says here, they are concerned that the true mean is actually higher than this.
Gotcha. Okay. Yeah. Just missed that reading part.
No problem. That's how we catch each other.
Yes.
Which of the following would be appropriate null hypothesis?
The first one?
Yeah, because that's what they thought, right? The null hypothesis was actually 1,500, or the mean average claim. So yeah, the first one. Okay, next information assurance company selects N equals 40 claims, sample mean of 1650.
Yes.
The distribution simply is normal. Is this a good assumption?
Yes. Well, didn't we in our reading anything over 30 is large?
Yeah.
The first one?
Yeah. I think.
Yeah.
Yeah.
That's I think, yeah.
Okay.
What theorem or law justifies your answer? That would be the law of um, large numbers. Let me see here.
Um,
It's actually, no, the central, right? As sample size
theory.
becomes always issues, it becomes approximately normal. Yeah. The central limit theory.
Yes.
Yeah, central limit theory.
Yeah. Which of the following is a test statistics is defined in this lesson? I don't know. Is that S? Because I was trying to figure out what that S was.
Yes, yeah. I was thinking the same. What is alpha? What is?
I know. Let me see. Test
Where
statistics.
is?
Okay.
What is S?
This is probably going to test.
Wait, is statistic Z?
I was thinking they will put P or alpha.
I think you're right because I could give the test statistics and its value, and it has Z. And
Because
yeah,
in the notes on 4.2, where Z is the test statistic, and the other thing, you can define the other thing. The first one's a sample mean. S is the statistic.
yeah. The p-value. Yeah. Well, then that makes a lot of sense. Then, here we go, because that's why the you solve for Z.
Z value is the
Yeah.
statistic.
We call this a test statistic. That's the Z right there. Okay.
Yeah, so is
That's that, right?
yes.
Okay. The historical mean of sales receipts at grocery stores. Let's see. Okay. So what is the Z-score of this?
Okay. Yes,
Have,
calculate.
So our mean is 50. I'm not sure if I have the right calculations in here. Significance level is 0.5. At 144. Oops. 36 is our number. 36. This is where I'm kind of confused about how to set up the
Because the standard deviation is given as a number.
40. $40
Or
right here.
yeah.
Okay. The standard deviation is 40. Okay. So I have a Z-score of negative
But it's $40.
0.9.
So how much is that?
Oh, shoots. Sample mean. I thought the sample is
36.
40 right here. I thought the sample mean was this one. So is this the number? 36 is the number? And then
Number of
this
samples.
is 144. So 150. So wait, are my calculations right? 144, the mu is 150, standard deviation is 40, number is 36, which gives us a z-score from the sample of that. So it's actually A2 minus B2 divided by this is square of that.
But well, I'm confused, a little confused. The standard deviation, it's 40.
Mm-hmm.
Yes,
Yes.
but it's $40. I'm making a formula, no, in my Excel as you, where I can put all the data, but I don't know is have to put 40.
Yeah, because I was going off of this formula here.
Yes,
Minus,
yes.
yeah, because this is the formula we used to do.
Yeah, but in that formula, let me see, you're using 40 as a standard deviation.
Right. Yeah, in this one 40 is the standard deviation right here. Standard deviation is 40.
And you got for theta 0.9.
Yeah, negative
Yeah,
0. Yeah, from the sample. From the sample, that's what it is.
yeah,
Which,
from the sample, yes.
yeah.
Mm-hmm. I
What
got
did
the
you
same,
get? Yeah. You got
0.9.
is the negative 0.9, right?
Yeah, negative, yes.
Is that what you got, Brianna?
Yeah, but it makes me worried because it says round to 3 decimal places and we only have one.
Yeah.
That's where it's. I'm not sure.
Yeah. The question is, we need to use the significant of. I don't know. I'm getting confused.
The historical catastrophe versus 150. Yeah, okay, this is where I don't know how to use this. Where do we put this in? The A equals 0.5.
Sorry?
See this right here, the A equals 0.05. That's where I don't know how to use that.
See, we don't use that, but I'm looking where we have to use that.
Yeah, let me look here too. I guess so is it because we just compare it, the negative 0.9 to the 0.5, and because it's less, it will reject the null. So then we reject it.
So when you put it in your applet,
Mm-hmm. Right
put
there.
0.9 in your applet and then
0.1841.
But that's the area.
If we do the negative 0.9.
yeah, and then just choose the left side, 0.184 maybe.
Yeah, 0.184.
0.184.
But that's. I think that's not.
0.184 is.
But here the question is, what is the CT score associated?
With this test, right? It was before we put in output. Yeah. All right. You know, I can do that. Let me do this to 0.9 and I'll let you guys know if I get it wrong. What is the p-value associated with the z-score from the previous question? Round to 3 decimal places. And the p-value would be the
Sorry, what do you put for number 15?
15. I'm going to put the negative 0.9 and I'll let you know if I got it wrong. I'll submit
I
my
will put
quiz.
the same. What's the p-value?
And then the p-value associated with the z-score from the previous question is
0.18.
p-value is I think it's this one, right? Yeah, I think it's the point. This one, the
Yeah, this one.
0.1841
Yes.
or 0.1. What inference did you make about the null hypothesis? So in the null hypothesis, I think it's going to be rejected, right? Because this is, she said that at 0.05, but this is lower. Is that right, ladies?
I think so.
Yeah, I
Or
think so.
Yeah.
Reject.
Yeah, reject. So our conclusion for this policy, there's sufficient evidence that true population mean is less than 150. Let me go back to the question.
Yeah, it's less.
Yeah.
But sorry, there's number 18. That's two sentences that sufficient. No. Sorry, I'm reading bad.
What did you put?
The last one.
So that's what I selected. We have sufficient evidence.
Yeah,
It's
because I was reading
everything
the fair one and I haven't read it that was insufficient. Yeah, it's sufficient.
sufficient evidence that true population. Brandy, is that what you got too?
I think so.
I know. Well, I can submit first. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the hypothesis is true? And I always get confused with this one.
Well, in the notes, a type 1 error is committed when we reject a true null hypothesis.
Yeah, so it's going to be type 1.
Type 1, yes?
Yeah. So researchers decided that instead of using levels, if it's he will use which of the following will be proved true. Okay. I saw it in here.
A little bit more. I don't know.
See, type 1, 2 errors. Okay, so with the null hypothesis is true, one.
Here says we choose alpha to be some small number so that the probability of committing a type 1 error is low. In that part before.
Okay, I see right here.
Yeah, we choose.
Okay. Okay, so since
But there's no
Okay. So the question is, researchers said instead of using 0.5, he will use. Okay, so it will be will decrease then, huh?
decrease, yes.
Oh wait, it doesn't say that though. Probability, so it's gonna be where is it? Which is a
Oh my gosh.
um
Tricky again.
probably the null hypothesis true will decrease. This experiment would be um it doesn't say.
Yeah, after the charter, below,
Uh-huh.
below, below,
Okay.
below.
Okay, keep going.
Yeah, yeah, there. If the alpha value
Uh-huh. Is small.
is very
True
small,
error. Oh, okay.
it will be large.
Okay, type 2 would be large.
Yeah, so type error will increase.
Okay, number 2, got it. Did you get that, Brianna, or are you already ahead of us?
No, I'm just you. It's
So we're looking at this part of the chapter. It's probably type 1 committing type 1 error is very small. The probability of committing type 2 error will be large.
okay. Okay.
Yeah, and then same
The
thing.
last one is 0.1.
If A could compute the probability. Huh? Sorry.
My God.
If A equals 0.5, compute the probability of committing a type 1 error. Okay, can you show us how? I'm going to stop my screen.
No, I'm thinking just because
Oh, you just think,
I read in that block, in that paragraph, that
okay.
they rounded to 0.05 to 0.1 for probabilities in type 1 error. I will show here. You see?
Okay. Where? Oh,
We choose alpha. No, this is equal. So in the null hypothesis, there is 1 in 20 chance that it will be rejected. Other common choices. Oh, he's not here. Nice. Oh no, I lost. I lost it. I don't know where I read that.
right there. Oh no, that's the same one. Let's see. The question is A probability of committing a type. So isn't A um about the same as the z-score?
Sorry?
Is A about the same as a z-score?
No, I don't found it here.
It says the type 1 error is committed when we reject the null hypothesis that is in reality true expectations committed when we fail to reject a null hypothesis. That is in reality not true. The value of A is the probability of committing a type 1 error. So do we use a probability app?
What do you mean? That CETA score must be rounded to decimals?
Let me see.
Because we have the CETA with 1 decimal.
Right.
It's not clear, and it's not a clear example when they use alpha
Yeah.
related to the CETA scores. I don't see that. Here says that the alpha only means that when the null hypothesis is true, there is 1 in 20 chance that it will be rejected at the 0.05 level of significance. So it says not only that how much is the probability that the hypothesis, the null hypothesis will be rejected. Just that, no?
Yeah, I'm still trying to figure it out. Values are rejected null if the p-value is not less than A, we fail to reject null. Brianna's so quiet.
I have no clue.
She's fighting with a computer.
Yeah, she is. Well, because in our homework problem,
there's something similar.
Write down the formula for computing the test statistic for the hypothesis test for a single mean when sigma is known. No, that's not it. Let's see. Assuming the non-question of A is the probability of getting a value of the test statistic that is extremely known.
Number 9, letter C, question in letter C.
In the quiz?
In the homework preparation.
Okay, let me look.
Oh, but there is no.
Number 9.
If the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? The answer is there was about 1 in 100 or 1%.
Oh, nice. Yeah, the analysis was done.
And the question
yes.
Here will be 5. But it says, yeah, but without a percent, no?
Yeah.
But what
that's the same thing. It's the same 0.05, right?
How you will put 5 in the answer? Just 5?
I don't know. How did you guys do it in your quiz, in your exam? Because I put it just like that. Like when I wanted to do percent, like 68%, I put 0.68. I don't know if I got it wrong or not.
I think you're only supposed to do, it said in the example, you just put like the numbers, so 68.
Oh, so see, that's why I got it wrong. So in this one, then we would say that it would be 5%, right?
But I think for this one, you round to 2 decimal places, so 0.05, because then that would make 5%.
Yeah, but it's the same as, do we just say 5? Let's see on this one. Yeah. So it's the same as saying.
Could you show your screen? Just to understand what we finally going to write there.
I'm not sure.
Because I don't know. Yeah, for me it's 5%, yes. But the alpha on the sentence says 0.05, so
I'm gonna put 0.05 and I'm submitting right now.
Yeah, I think that's what we'll do too.
I'm submitting.
0.05.
Yeah,
Yeah.
that's what I put. And we missed one.
We missed one. Wait, I'm submitting mine too. Because
We
we can
missed
go
number
back.
18.
What number?
18.
13?
18.
18.
Oh, I have 17 and 18. I thought it was reject the null hypothesis, but it was failed to reject the null hypothesis.
Yeah.
Oh, I got that one wrong.
Oh, I just clicked the other one.
And then 18,
The last one was sufficient. We have sufficient evidence.
insufficient evidence.
Sufficient or
Yeah, we put sufficient, but I guess it's insufficient evidence or something. I don't know. What do you guys think?
Oh, maybe it's we have sufficient evidence. I don't know. I know. We got a 95 and I'm kind of happy with that. So I know we should know what it is,
but the samples are 36 for the new mean.
Yeah. I think because we knew that there wasn't, that it was less, right? That was this one. That was our calculation, sample mean. Well, we know that, I guess it's insufficient because we know that it was less, so we don't have enough evidence. Okay. All right. Well, I guess we can go back and do the quiz, redo the quiz on our own and stuff. But good job, ladies.
Good.
Yeah. You guys have, I guess we can end the call now, huh?
yeah. We'll see you Tuesday then.
Yeah. Hey, have a good one.
Thank you.
Bye.
Bye. Bye.